Hello there! Happy Friday night. Welcome to Cynthium Live Hack once again. Good old Friday night live hack. Hello there! Happy Friday night. Welcome to Cynthium Live Hack. I think I got rid of the... Sorry, I was just looking to see if I got rid of the noise that we had last week, and I think I figured out why it happened. It was because I hit start recording and start streaming at the same time, and I think there is an issue with the software. Hey Nomad, thanks for joining. Well, tonight I have some unfortunate bad news. Sometimes you want everything to work out perfectly, and it just doesn't. That's the way it goes. That's life. Such is life. So, I'll tell you what happened. So this week, I put in a lot of work into this XY movement system, the stepper system here. Did a lot of testing, found out that, you know what, if you use half stepping, quarter stepping, and 16th stepping, there's actually some jumper settings right underneath these motor drivers where you can get, you know, these little PC jumpers. Used to find them all on all kinds of like sound cards and stuff. These little guys. You just put these jumpers on the pin settings and you can get it to the steppers to do different stepping patterns. So practically that looks like the stepper just slows down quite a bit and like has more resolution, but it doesn't move as far. So with I actually had it with half stepping. It would move, you know, just like a, you know, if let's say if the steppers were in full step mode, they would move from here to here. Well, half step mode would be half of that, so you get more resolution, and quarter step would be even less than that. I didn't get it to go down to 1/8 step. It just wouldn't work. So it's probably just the way I was driving it with Easy Builder. And so that was some good findings. I also like used a higher voltage, and turns out that doesn't really matter. Each here, I'm gonna grab the stepper driver. I'll grab one right now. So each one of these stepper drivers, it has a little potentiometer at the bottom there. Sorry. Left is right and right is left. So that little potentiometer will adjust the amount of current that the motor driver can put out. And so I figured, you know what, my steppers are having a bit of a hard time like actually making the Rock'em Sock'em robots move. So I ended up putting 3-in-1 oil over everything just to make it slide a lot better. And then I figured, you know what, I'm going to set the current a little higher so that it'll drive the steppers a lot better. And then I'll kind of tone it back if, you know, if things aren't, you know, we want to tone it back just so that the steppers don't draw that much current, and we'll just draw just enough. So I cranked it up on all of our stepper motors, and then I started testing it. And unfortunately, I burned out the steppers. Kind of a catastrophic failure. I tried swapping the drivers around, and I did have one stepper that survived, so I was swapping the drivers around to see if that was the case, if it was the drivers that burnt out. Unfortunately, no, it was the steppers, so I melted them. And you guys know how much work I've put into this stepper driving system. It was a bit heartbreaking. So tonight's hack is going to be me rejigging the entire system for a different kind of XY movement system, unfortunately. So that means we have to rethink, do we even need an Arduino? We can probably do this whole thing with just an EZB. And we might be able to do it with, you know, we can extend the camera and go all the way back down into the bottom. It wouldn't need an IO Tiny to drive the camera. That's one thought. We could use the Arduino just for fun, but I would need a servo shield to make it work. So, yeah. Kind of heartbreaking, unfortunately. So much work was put into making this stepper stuff work, and I just went and wrecked it all. I think, yeah, it's a bit of a fail because I think these steppers need about, I think it's 8, no, the stepper drivers need about 8 volts to 36 volts, and I was doing 12 volts, which is fine. But I think the stepper motors themselves probably only required about 5 volts to drive them. And I was overdriving them with 12. And then I increased the current to like past 1 amp, probably about 2 amps per motor. And they just didn't like it. I think I probably melted the wires inside of them. And they probably shorted out or something. Or just opened up. Because only one stepper works now. Sad days, you know. Some days you have some great success, and some days you fail like a boss. And today's one of those days. So yeah, today we'll be taking this apart, sadly, and probably putting it together with a servo driving system. I did think about one thing though. I could drive like the stepper system, rail system, with maybe servo motors. They would likely stick out quite a bit. I'd have to rethink that. Possibly could do it. Let's have a look for a quick second at. I think I have an example over here. Oh yeah, here we go. So here's the linear rail system, and that's the stepper motor there. If I replaced that and drove this worm gear system with a servo motor, continuous rotation servo motor, it's geared. It would likely be able to do it. It would just be kind of tricky to figure out how. Because I would need like a servo horn that kind of interface to this, or I outright replace this whole thing with like a 3D printed servo thing that attached it right here. This one's actually broken. There was a spring and a piece here that attached, and it allowed it to kind of clutch out if it hit the end rails. So it's kind of a neat system that way. But I could possibly make like a linear servo system, but I'd need to figure out a way to have it clutch out as well, because otherwise we might burn out the servo motor, which would not be good. We've burned out enough motors today, we don't want to burn out anymore. The nice thing about this rail system is that we can actually take this stepper motor right off of here. There's a couple of screws. Well, helps if I have the right screwdriver here. Just take out 2 screws and the stepper motor comes right off. Just like that. Easy peasy, I guess. It would be nice to like just, oh yeah, we can just replace these and be on our way, but I think that I think I just spec'd everything out too close to its limits, let's say. I was hoping for the best, but I think I just set myself up for a bit of failure in the way I've spec'd everything out, because running these little tiny steppers with 12 volts probably wasn't a wise idea, but it was working for a little while, but until I overdrove them and expected too much from them. So I think I learned a lot though. Like, I learned that you can do some pretty neat stuff with those steppers. You can make like little 3D printers and little laser engravers with those, but you probably want to drive them with a little bit less voltage, and they won't be carrying as much load as we were doing as well. So moving these robots around definitely is not an easy task. There definitely takes a bit of torque to move them. So yeah, those steppers weren't up for the task, I don't think. So yeah, we're gonna have to figure something else out. Maybe we'll look at maybe this linear movement system with servos. That would be pretty neat to drive this. Or we can move to a different system that's driven by servos. I'll show you that. I think I have it on my page here. I'll transition over. Okay, so this was a design challenge with Rock'em Sock'em Robots, and you can see here that they used a linear guide system, which was interesting. Now, the one issue with this system is that the Rock'em Sock'em Robots can turn. So you see this plate? I actually modeled my system kind of after this because I like their plate idea. Well, that plate can actually turn this way and that way freely. So the Rock'em Sock'em Robots can turn their bodies unintentionally and get out of harm's way, I guess. So what I would need to do is do like a little key or something, just like drill a screw through here so it doesn't actually turn. Could be tricky, or we devise a better way. I haven't really thought about it too hard. So I did the same sort of thing with the servos and drilled some screws into the feet posts and then pushed them down with servo motors. Here, I'll just play this video so you guys can kind of see. We'll skip past the pleasantries and get to the good stuff. There we go, right when he flips it over, perfect timing. So he's using two kind of heavy duty servos per bot, and they're in a linear rail system. So he used, I think, this PCB material, and I have some of this material that's just at home. It would be nice to be able to use that. And then he used just kind of like a couple of nuts and washers and stuff to put this together. So I would have to change a few things with my system to make this work, and I would have to grab some of that PCB material from home. That'd be handy to use. I might have some in the back, but I'd have to go check. But this is definitely another option for making these guys go. And then let's see, let's go to Thingiverse for a second here. I think there is some designs for linear servos. Yeah, stuff like this. I wonder if there's any videos to go along with any of these. There we go. Ads, let's skip those. So that's a pretty neat system. Just got a continuous rotation servo. I can actually just modify some of our servos to be like our micro servos that we have to be continuous rotation. Or I could use some heavy duty 360-degree servos that we have as well. It shows the assembly process. I'm surprised he doesn't have a screw that goes through there and holds that piece in, kind of like that. Oh, he has some pretty neat projects, this guy, though. Potent printables. That's pretty funny. I'll definitely subscribe. Seems like he has some pretty neat stuff. Let's go back to Thingiverse for a second and look at a different design. So this one looks a little finer. I don't know if I would trust that. I think the teeth would probably like rip off of that pretty quickly. No videos, unfortunately. So if you're just joining us now, we have to do something different with the Rock'em Sock'em Robots XY movement system. I burned out the stepper motors that we were using, so it's a sad day. So we're looking at different kinds of systems here, like linear servo systems. Or I was just mentioning that we could use this linear rail system that is adjusted by servos. But as I was mentioning, that it's just that these plates can actually freely spin left and right, and so it doesn't line up the robots very nicely when you use this kind of system. So you know what? Yeah, let's not do this system. I'm gonna make a decision. There's no way for the robots not to spin with this kind of system. So we're not going to do it. We are going to do a linear rail system. And we're going to 3D print stuff that, well, that's weird. Thingiverse died. We're going to do a linear rail system, probably utilizing something like this. And we are going to use limit switches to find our limits, I think. Just like we did before. Maybe we'll try to use the existing linear rail system and just add servos to it. That is going to be a challenge, especially for the, you can't see what I'm pointing at right now, but here I'll switch my view so you guys can see what I'm pointing at. So especially for the smaller DVD drive system, the smaller linear rail system, because it's super tight in there, and to try to get a servo in there is going to be difficult. But possible, let's say. So we're going to have to likely take the Arduino out of here. We won't need that. We won't need 12 volts anymore because we're not driving steppers. So we can take out our linear, our switching power supply right down here. That was for regulating voltage to the servo motors. We won't even need that anymore because we'll just drive everything off of 7.5 volts. So we can get rid of a lot of electronics. A lot of this wiring will be gone. But yeah, we're gonna have to figure out that new system of driving these. So we could probably do some stuff with this guy, just because we can just do some testing, see what we can come up with. The 3D printing part is going to be the painful part, because it's going to take some time. So we're not going to give up on the linear rail system, but it's going to be a little different. It won't be stepper based, and it won't be like a true DVD drive hack. It'll be like a modified DVD drive hack, unfortunately. So we're getting away from the authenticity of the hack of that hack portion. And yeah, I think we will. Let's just see if an Easy BB4 fits. No, it's too high. So I would have to modify the Easy BB4. Not have like a power base. Modify the pin. Probably come out this way. This Micro HDD connector. Probably desolder it and just make some sort of connector that goes here. And that could fit in down here, or exactly where the CNC shield plus Arduino is. We can take that right out, put this guy in its place, because we're going to have a full servo-based system. We won't use stepper motors anymore. As fun as that was, unfortunately, just, yeah, like I mentioned, when you try to turn up the current and get some more torque out of those steppers, when they're that small, they can't handle it. And things go badly. So, I guess let's start the process of taking everything apart. Sad days, but let's do it. Sorry, I'm gonna bring up the chat. See if you guys are saying anything. If you have any, tier emojis to add to the chat, definitely do that. Because that's what I'm feeling inside tonight. All this work. Now we gotta chalk it up to a learning experience, I guess. I do like that these linear rail systems actually lined up nicely with these mounting holes on the Rock'em Sock'em robots. That was something that was unintentional, but really neat that it did work out that way. So begins the process of re-engineering the movement system. There's one out of there. Well, I've had these things in and out so many times that it doesn't take long to take them out. I'll put these back so I don't lose them. So, does anybody have any happy news today? Anything good happened today? I need some cheering up. Fresh and better start, yeah. Start fresh. I was thinking about just not having a live hack today, but I figured it was too close to the time to give up, so I was thinking about just giving up for tonight and then starting again tomorrow, but let's just start tonight. I figured, what the heck. Sometimes you can't just run away from your problems, you just gotta tackle them head on, right? Today is that day. I kind of wanted this project to be Arduino based because I wanted to do some testing with the Arduino and as an EZB with DJ's firmware, and it worked out pretty good. Like, no complaints. It worked better than I expected, actually. But I think it's going to be easier for us to go to the EZB instead, just because it has everything natively supported in Easy Builder, and our entire project's in Easy Builder, so why not? And like I said, we can extend the Cabra cable all the way down to this board. Just need to make an incision somewhere to make it happen. Here, this is the camera I'm talking about right here. And so what we want to do is actually get rid of this whole backpack and just run the camera probably just along the back and then down here. And we're probably going to have to make a larger hole to fit the camera wire down through there. So we'll do that as well. Prep all that. So detach these servos. Oh yeah, some of them are hot glued together. Use a bit of alcohol spray. Take this stuff apart. It's the beauty of hot glue. You can always erase it off of there by just using a little bit of isopropyl alcohol. I use the 99% stuff. It evaporates a lot faster. Doesn't have any water in it. And we also have these analog sensors that will plug into the EZB easily as well. I guess we'll need this this harness. It helps drive the IR LEDs, and also pulls up one of the lines to 5 volts, so we need the receiving line. So we will need this harness still. So I think maybe I should have left them hot glued together. Would have been easier, I think. Let's do that now. Just need to blow on it for a quick sec, evaporate that rubbing alcohol, or else the hot glue won't stick to it. Alright, there we go. Okay, this is for the Arduino. You're coming out. So there's lots of hot glue on the bottom as well, so you have to soak this thing in. Same with the switching power supply. It's got a bunch of hot glue underneath it as well. So try to pry it up. Oh no! I broke my dental pick. What did I do that for? What I need is an O-ring pick that's a lot tougher. Okay. For prying applications and electronics, I definitely recommend one of these guys. It's an O-ring, a 90-degree O-ring pick. It's much better than snapping your dental pick off and this kind of thing. Whoops. Alright, there we go. glue off of there. Next is the Arduino. I wouldn't say everything is a waste. Definitely learned a lot about the stepper shield. I mean, we can definitely use this for another project. I think it would be pretty cool to make a tiny little laser engraver. There's I think there's a bunch of open source projects that use this exact board to do that kind of thing. Make you get a high powered laser, you attach it to a linear rail system like those DVD drives I was showing you, these guys. You make an XY sort of table, and I think you just move the table itself. It moves around like this. And you just have the laser engraver steady up above it, and then the table makes the image with the laser. And then you gotta have a way to shut the laser off, I think. So you just use like a MOSFET or something to drive it, and you're on your way. Okay. Arduino is free. Free from the hot glue, I should say, not free in price. Alright, let's get the remaining hot glue out of here. I think I will leave this the enable button on here, just so there's not a large hole, gaping hole, and that, it doesn't look that bad. Maybe I'll remove it later, but for now it can stay. Okay, that will connect to the EZB. So, EZB. So the EZB has a microDeans connector right here that we won't really need to be in that place, so we're going to have to adjust that. What I might do is actually just run a couple wires to a barrel jack and just go right to that hole that we had already drilled right here and make use of that. It's the exact size of a barrel connector. So maybe we'll do that. We'll hot glue the barrel connector down. The only thing is that the barrel connector has nothing to really hold it in place besides hot glue, and if I keep on plugging in and out, it will likely get displaced. I guess it'll likely pop off. So I have to think about that. But yeah, I guess while we're here, let's also take the backpack off of the blue guy. Don't need the backpack on there any longer. Just see how long the camera cable will go. I guess what I could do is try to squeeze it, fold the wire, squeeze it, like remove all these connections here and to feed them through that hole, and then put the connector on the other side. It's actually longer than I expected. But we definitely need a little bit more play because it's going to move around like that. After I put on all that 3-in-1, man, these things slide around so easily now. So let's put some of this stuff aside. We'll put this over here, so we're going to modify it. I wish it was just a little longer actually, because I don't want to have to, if I use one of the extensions that we have for this thing, it's going to make it like this long. We don't need, well, I don't know if you can see that, but it's going to be the extra 2 feet long. We don't need that much length. It's a bit crazy, it's a bit much. I wonder, do you think we could just use an iotiny? I think that might make things a lot easier actually. Let's count what we need here. Just gonna remove this little battery. We don't need it any longer. Get some more of this hot glue off of here. Okay, so we have 4 servos for the punching. And then we need 4 servos for the movement. We need a camera. And we also need 2 analog ports. You know what? I think we could max out the iotiny and make it happen just on 1 iotiny. It would save us from doing mods on that EasyB. Kind of crazy that it all would all work off of just this one little iotiny. Sorry, just get rid of that hot glue. Guess we don't need this little guy anymore, but I don't know, it doesn't hurt having it on there. This would definitely make things a little easier. We can, instead of using the hole up here, we could just use the hole down in this area. That would mean I would have to remove this base plate from the iotiny, which isn't a big deal. There's a whole lot more booze, as DJ calls it, alcohol. Yeah, I wonder if DJ is going to be coming back pretty soon. It is October, so I'm guessing it could be any day now. Definitely missed the guy. So many live hacks without him. Just felt kind of wrong. Alright, let's get rid of all that hot glue. And let's see if this fits nicely now. You know what, I am going to get rid of this. I'm going to desolder that wire off of there. The iotiny will fit a lot flatter on the bottom there. Yeah, I'm kind of impressed actually that this whole 2-robot system will work off of 1 iotiny, just enough ports. We could even actually, I never thought of it, but we could use the RGB 8x8 display, matrix display as well, if we wanted to. I don't know if this is the right one, but I'll have to look afterwards. Oh yeah, here it is actually. Perfect. So that one, we could hook up and it could be our point counter and our like countdown and our like round display, you know, like round 1, round 2. So we could actually have that mounted in, mounted on one of the corners maybe, like so. I don't know, where do you guys think we should put it? Hey, Justin. Yeah, definitely some professional prying with the classic O-ring pick, the 90-degree one. These are pretty handy. Don't recommend using dental picks when you're prying, but these guys are pretty strong. So where do you guys think I should put it if I were gonna to have a round counter display? Not round as in the shape of round, but like I said, round 1, 2, or 3 sort of thing. Feel like maybe on one of these posts, somewhere visible, but it doesn't really look that great up there. Could have it just like down here somewhere, covering up one of these holes. Yeah, that seems like it'd be a little nicer, I think. You think it looks good up there in the corner? Like, hot glue it against one of these pins. I don't know if you guys can see that. Maybe not behind the red robot, but over here. So if we had like a camera angle from this area, it would actually look pretty good. All right, yeah, I think that'll do. I like that. Let's see, where's the iotiny gonna be at? Oh, perfect. So iotiny is just down here. We just run this cable just in there. I think that's gonna work out nicely. I like it. Because I was just thinking, you know what? The iotiny has this I2C port. We're using every single port, so might as well use I2C as well. So let's throw a little display on there at the same time. I think I might just get rid of this button, even though there's going to be a hole there. Aha! You know what? I think it will work out nicely, actually. I might be able to run this right through that hole. Let's have a look. Okay. I think we're almost free. I think there's a bit of hot glue at the bottom. And likely on the other side, actually. Come to think of it, yes, there must be some on the other side. And sure enough, there is. Okay, there we go. Freedom! Well, if we want to fit that this connector through, I'm gonna have to drill that hole a little bigger. Or we do what I explained with the camera, and we pop the pins out of here, push it through, and then put the connector back on, which we could do as well. But this little wire is bothering me right now, so let's move to the workbench and take that off of there with the soldering iron. So, transition the view here. There we go. Get my water out of the way. Yeah, I could definitely do that. I'm wondering, is that what is it called? Politically correct PC nowadays? Or do they still do that in boxing matches? Do you know? Like, do they still have women that in a bikini holding up the round signs, round 1 or 2, or is that like passe? Like, they only used to do that back in the day. It doesn't happen anymore, sort of thing. Yeah, probably not PC. Good call, Justin. Yeah. It would be funny, but I think I may get in trouble. Likely from my wife, who watches this stream sometimes. printing out a bikini babe for holding up the sign. We could print out like maybe a robot bikini babe, like that looks robotish. And maybe like you know, the female robot from the Transformers movie, RC, I think her name is. Maybe we can print her out. That would be kind of funny, and she could hold up the scoreboard thing. Maybe that would work. Just as a joke. All right. Soldering iron is warmed up. Let's get this wire out of here. We don't need it. There we go. Okay. Just put a little bit more solder on the tip there. Keep it tinned. I think that's good. Let's transition back to our other view here. So, sorry, I'll spin this around so you guys can see better. Our tiny is going to go right down here. It's a good place. This guy, you know what? I think I will just like pop these guys out of the connector, push it through. Let's see. Yeah, might as well. Let's just do it. Actually, I think we'll need a dental pick that has a pretty decent end on it. Pry those out of there. So if you guys have any questions about what's going on and why it looks like I'm moving backwards on this project instead of forwards, definitely let me know if you have any questions about it and I'll answer them. But otherwise, you can go to the beginning. There's a big, long, drawn-out sob story about why I'm at this point. So have a look after the stream is done, and you can get the full story. Yeah, it's definitely a sad one for sure. Tearjerker. Just a lesson in failure, I guess. Or a lesson in like maybe R&D in general. Things don't always work out like you planned. And working close to the edge of specifications is never, well, it's always a risk, let's just say that. Okay, there we go. Pull through. Make sure all these little terminals have their associated tab lifted up still. Perfect. I didn't push those down accidentally. All right, we'll bend the plastic back on this connector. You have to do that because we stretched it out a little bit. And then we'll pop those pins back in. Alright, there we go. It's a method you can use if you don't want to drill any more holes. Done. Okay, so let's hot glue that in there. We also need a tiny speaker, can't forget that. And then we'll hot glue the speaker down as well. Plugged in, right on. Oh yes, tonight's diffusion oils today are, we're doing the classic Pan Away from Young Living and Stress Away from Young Living. I put in equal parts of each, and it's supposed to smell like root beer. Let's give it a try. You know what? That's the closest I've ever got it. It does smell definitely like maybe like a root kind of scent, but mixed with maybe like a mint or a peppermint. I think the Pan Away has peppermint in it, if I'm not mistaken. It doesn't have the ingredients, so don't know. Or maybe it's it's like a wintergreen, I think, rather than a peppermint. Anyways, smells good, that's for sure. Oh no, we're running out of glue. More hot glue. There we go. Put a bunch of hot glue around the barrel jack because we're plugging in and out of there with a barrel plug. It's likely going to loosen up. So, I don't know, I'll just put a little bit of hot glue in the corners. And then we'll put the speaker right there and just put a little hot glue around it. Don't want to get any on the speaker membrane, but get it around the sides. There we go. Strings everywhere now, and we can likely plug this guy in. We'll just wait until stuff cools down. Okay, that's the way it looks right now. Looks like it just fit it in there, actually. Put it up against the side so it doesn't wiggle around so much. I guess this has to be out a little further. And we'll glue that down later. Nice. Yeah, I didn't buy a second one. They're pretty hard to find these days. Actually, I think you can get it on Amazon, but it's not this the classic Rock'em Sock'em. It's a little reissue, I think. I don't think this is even actually the classic. This is from 2001, actually. So this is another. I think it's closer to the original, but. Alright, I think everything is cooled down enough. Plug stuff in. Probably start plugging some servos in as well. these will go to the analog ports. So one goes to, well, it says +5, but it'll go to 3.3. One will go to ground. Oh, actually, two will go to ground. And then these two will go to analog 0 and 1. One thing I didn't think about is limit switches. So if we do something smart with the potentiometer, we won't need to have limit switches. And what I mean by a potentiometer is on the servo motor, each servo motor has a potentiometer to give its position. So with the servos that are going to have to do multiple turns, usually you do a few things. You can do an encoder, you can do a multi-turn potentiometer, or you can do limit switches. And so, thinking about it, I will have to do likely a multi-turn pot if I want to continue to use servo motors without any additional I/O, I guess. Because I could do it with the EZB, and we just use limit switches on either end to let us know if we've reached the end of travel or not. But I've already hot glued this IO Tiny in here and hooked everything up to it. Column A or column B? You know what, I've never tried like a multi-turn pot with servos. I think it'd be interesting. And I think that we probably won't be able to use this linear rail system, to tell you the truth. As much as I would like to. Because this portion here is just going to be way too hard to get a servo in this area. Otherwise it'd have to stick out, I guess, pretty far to reuse these guys. And I would have to do some metal cutting, likely, to get a servo into this section here. And I think that would be actually fun to design our own XY linear system with the continuous rotation servos with multi-turn pots, because I think it would be a fun challenge to try. Of course, I don't have any multi-turn pots here. I just have your regular old potentiometers. So I would have to order those and then figure out a way to mount them on a 3D printed system. And I also have to figure out, how I'm going to mount my servos and everything. And I think that the best way to do all this would likely to be to design it myself. Instead of trying to depend on somebody else's design, just figure out a way to do it on my own. Probably like based on what there is out there. Oh, stupid ads. Oh yeah, tonight we're playing the Spotify copyright-free playlist. It's not the 2019 version, it's just a regular, I think it's called the NCS version, which is kind of like YouTube has the NCS, no copyright something something. If I used limit switches, I would need 2 for each axis, so I would need 8 limit switches in total, because we have an XY axis for each robot. So that's quite a few limit switches. The EZB can easily handle it. We have tons of ports left over if we use the EZB. But I think I'm up for the challenge. I think I want to try this multi-turn pot sort of linear system. It seems like You know, we got to this point, we've tried so many things to get this to work with the stepper motors. Maybe we should invent this new XY sort of system with continuous rotation, multi-turn pots, and 3D printing. I think it would be a fun little challenge. Wondering if I should start tonight or just leave it for another day. Well, actually, we don't really have much else to do right now, so we could start working on the Tinkercad or designing it in Tinkercad, seeing what we can come up with. It would be kind of based off this kind of design. And so when I say XY gantry or XY table, so this is, let's say, the Y, and then this is the X. So you just get a two-direction system. So what we would have is like a servo here, driving like a gear system to move this up, and the potentiometer would have to spin a couple times, probably 2 or 3 times, and then it would tell us where our position is for the servo, and if we can go further or come back. And then we would drive that with a joystick. And so we'll go grab the power glove for a quick second to show you something. So when I was making the power glove, not only did I have the accelerometer built in here and the fingers working and the thumb working, but I also got this D-pad to work, to show up as a joystick D-pad. So I was thinking that we could probably control the robot with the D-pad, and then when it's in position, start punching. Could actually operate it with the fingers as well, like get it to turn, like move left and right with the fingers. But I think this makes more sense. And so what I do is have it on my arm like this, like kind of get the robot into position with the D-pad, and once it is, take this hand away and just like start punching to try to get the other robot's head to pop up. And so we did that in a previous live hack where we actually got that working with the accelerometer, so that when I punched, the robot would punch. I think I did have that on the last live hack. So check that out if you want to see me doing that. But that's what we'll do in the future as well. So once we have that XY system working out, we will use the power glove to make it happen. So what do we have to do? Yes, we have to extend the camera cable. We do have to get that through that small hole if we're going to do it that way, which is entirely possible. And then we'd have to extend the camera cable to get over to the Iotani. I might just build an extension, like solder an extension together, because I don't want to have 2 feet of wire to have to deal with the extensions that we had from Easy Robot. You know what? I might have something pre-made. Let me have a look. Yay! I guess today's not all bad, because look what I found. An extension that's only this long. Yes. So I can plug into right here, the camera port on the Iotani, and then I can meet up with this connector here once I string that through, which is going to be quite tricky, I think. Let's get it done. Let's do it. No sense talking about it any longer. Let's just do it. Oh man, yeah, that's gonna be tight. That's so small. Oh man. Do I want to even try it? It's one of those things. I know it's not going to fit. It's not worth the attempt in trying to like squeeze that right through there. What we're going to have to do is pull this wire out and then drill the hole bigger and then put everything back in. It's just a roller coaster tonight of ups and downs. Okay, let's do this. Okay, need to remove the hot glue on this connector. We're gonna have to pop these little pins out of here, pull it through, and then do some drilling. Okay, I gotta remember which way these pins go in. Probably matches any regular servo, I'm guessing. I think I did it that way. Yep, perfect. Okay. Let's do this. You guys have any stories of times where you had to kind of redo a project or start from scratch again? Ugh, I need a different one. Any heartbreaking stories such as my story tonight? Well, luckily we don't have to start from scratch, I guess, but we are going a ways back. That's for sure. The XY gantry system, I think, was one of the first things I worked on this project back in part 1. Today we are at part 10. So I think the majority of those episodes had to do with the XY gantry system, which is sad. A hard lesson. Oh yeah. Hey Martha, thanks for tuning in and checking out the live stream. Yeah, I guess you have had to do the Nimbus a few times on the Nimbus's brushes. So I think I posted a link if you go see the, I think it's that cab from Back to the Future. I posted a link to Martha's blog, and I think she has the Nimbus 2000 on the blog if you want to see it. But yeah, I've had to help Martha a little bit with that. I don't know, I guess you could call it the brush portion of the broom is a pain in the butt because you have to flex all these sticks all around this form and make it look like a broom, but a broom that's like tied tightly together. And you can't really have too much, I guess, showing. You can't have too much string and everything because it kind of looks bad. So it's definitely a huge challenge to get those sticks all like kind of bowed in the right shape. So there's a lot of soaking of the sticks in water. There's tried all kinds of things. Okay, I need to drill this hole a little bigger. I guess with, I don't know if any of you guys knit, but Martha's knit a few things, and I've seen her have to tear it all apart just because it didn't work out. It's pretty much the feeling that I have tonight of having to tear everything apart. Okay, so we'll get a decent sized drill bit. So we got to fit a whole bunch of wires through that hole. Yeah, I think that'll be good enough. Oh man. Well, I'm looking forward to your secret J5 project, Justin. It sounds pretty awesome. Oh, Sparky, your robot had a few redos there, Nomad. That's too bad. Well, that went through a lot faster than I expected. Whoops. I guess the plastic is thinner than I thought. Okay. So, let's pop all these little guys out of this connector. Feed it through. So, anybody have any good jokes to lighten the mood tonight? I think I've said all of my jokes. I think it's time for me to find some new ones. I think I got all my jokes from like joke books that I used to take out of the library when I was a kid. I think the only books that I would take out of the library were Tom Swift, science fiction kind of books, which my brother got me into. And like comic books like BC, Archie, Family Circus, all those kind of books, and then joke books. Those are my go-to books that I would get out of the library. All right, fit these ones through as well. And then we have to do the tricky task of fishing those wires through the other hole here on the other side. Maybe these pliers will help. Okay, what I could do is just kind of try to push them. All right. Don't want to bend any of these connectors, but try to force them through here. I think we've got 4 out of the 6 through, which is good. Just 2 more. If Dr. Watson is not the most famous doctor in the world, then who is? Then who is? Is it a question or are you saying Doctor Who? Seems like it might be a statement rather than a question. Alright. We've latched on to number 5. Doesn't seem to want to come on out. Okay. One more. is just the camera wire. Then I have to do the servo wire after that. Darn. Okay. Almost there. Camera wire is through. Yay. Happy days. Okay, let's see how much slack we can. I'm gonna have to spin this around. Yeah, we will. Well, it looks like our music. Oh, I thought it stopped. Nice work, Martha. You got the joke. That's a good, definitely a good geek joke. Thanks, Justin. Oh, sweet. I think we almost got the servo wires through. There's 2 of them right there. Yes, okay. The third one came through a different hole. Whoops. So we'll try to push that one down. Try to hook that other wire and pull it through. This is definitely like dental work for sure. Maybe we'll try from the side, it'll be easier. There we go. Okay. This is the last pin to put through the hole. So close. Sorry that I'm blocking everything. Just an awkward position. We got it. Happy days. Happy days. There we go. Okay, perfect. Let's put this connector back on. There we go. Perfect. Back in business. Let's put the camera connector back on. Make sure all these just tabs are pushed down. Man says to his wife, "This hearing device gives me gas." His wife, "No, it's not. It's the first time you hear them." Nice. Okay, just want to make sure all these 6 wires are in the right order here. I'm actually gonna try to compare it to another camera so I know that I didn't mix up the wires. Okay, just like that. 6 of the wires in this thing at the same time is definitely a lesson in patience. Okay, there's 2 of them clipped in, 4 more to go. Oh, you know what? And I even messed up. 2 of them got switched around. Sad days. If we don't get it right, the camera will not work. So, good idea to get it right. Almost there. Okay. There we go. Camera connector, all connected up. Clip the extension onto it. Actually, let's check if the extension is actually correct. So it's just in my bin of things, so we'll have to see. So the wires should match up, blue side, blue side. Yeah, I think that should be right. Okay. Connect these guys back up. Okay, there we go. Why was the robot mad? Because people kept on pushing his buttons. That's pretty good. That's what I should do next. I should focus on robot style jokes. I've always focused on pirate style because it's just fun to have a pirate voice, but robot voice would be pretty good too, actually. Okay, that wire's not that flexible, but oh well. Okay, so I need to find myself a 7.5 volt, 3 amp barrel jack power supply. I think I have one around here somewhere. They're all 12 volts. There we go. Oh no! All there is left is a box. Volts. 12 volts. Where have I put my precious power supply? I know it's probably around here somewhere. Let's see here. This could be it. Well, this one's 7.2 volts, 1 amp. Well, it'll do for testing. Probably only be able to have one servo work at a time, or else it'll brown out this supply. Okay, so let's connect this up, see if the camera light comes on, see if we get the IO-tiny chime. See, this is the issue I was kind of explaining before, that if we use the same sort of XY gantry system with a linear rail, or sorry, it was kind of like a PCB rail system, these guys can turn like this. So if they're both kind of turned they'd be punching in the air, so not be helpful. So we need to have a system where they're locked in place to move like that, back and forth, but they don't twist, because that could be counterproductive. Alright, so plugging it in. Awesome. Okay. We got our chime, we got our camera LED working properly. We can check our scoreboard, see if that works. Oh yeah. Yeah, our scoreboard works. But one thing I didn't realize that it's upside down. Yeah, so our voltage is lower than the default battery voltage. It's probably lower than 7 volts, I'm guessing. So I may have to extend this wire because we have to have it up like this. I forgot about the orientation. You know what? If we did all our animations upside down, it would work to be like this. Maybe. Seems a bit ridiculous to do all the animations upside down. So I might extend that wire. So, well, we do have a little bit more. You know what? I think we could get away with it. Just have to pull it through a little bit more. Squeeze it on through to the other side. Okay, I think that might be long enough. Let's have a look. Oh, just barely. Yep, that'll work. Excellent. Holy moly. Always reaching limitations. Okay, we'll pop that off, put it to the side. So, I'm probably gonna try to figure out a little way to kind of get this hidden away a little better, I guess. Maybe put a dab of hot glue right there. Hold that in place. So I'll have to hold that for a few seconds. Yeah. Definitely check out this video after it's all posted and done to get the full story. But I'm starting over on the XY gantry design because I burned out all my stepper motors. Oh, except for one. One was still working. But yeah, I just allowed too much current to get to them, and I think I opened up the coils. So, unfortunately, we're gonna re-engineer the XY gantry system. So, yeah, I could go with a method that uses servos with these slider rails, but I didn't like the idea of these guys twisting. So we're gonna design our own 3D printed XY gantry system. Put linear servos, I guess, into there. I'm going to devise the linear servos with multi-turn pots. Something I've never done before, so that's why I'm kind of intrigued about that challenge of doing that. Okay. Camera wire is decently mounted. What else do we have here? So as you can see, there's nothing left under here. Took all these guys out because they're not working anymore. It's a sad day, but it had to be done. And we're going to just use an IO Tiny instead of the Arduino because we don't have to drive any more steppers, so we don't need the Arduino stepper shield. We don't need this little power supply, switching power supply any longer either. Actually, I'll pop that off because we're just going to power the whole thing with 7.5 volts. We don't need a regulator at all. The reason why we needed a regulator before, because we were powering these guys with 12 volts, because I think they needed 8 to 36 volts. 12 volts seems reasonable. I didn't have a high amperage 8 volt power supply, so, and yeah, or 9 volts for that matter. And I even brought in my epoxy putty. I was going to use that to adhere these pins here to the XY gantry, but don't need that any longer. I might need it again for depending how I mount the XY gantry. So we'll I think we'll take some measurements here of how far these are spaced, like get the length of what we need, and then we can start designing the 3D printed XY gantry. We'll take some measurements of these heavy duty micro servos. I think we'll try to use those because we might run out of room. I think that's the best idea. Let's just look at the size. I'll grab a HDD servo. So yeah, what I'm worried about is thickness, basically, because these guys were such low profile to move this this x-axis, I should say, I guess, that if we had a servo like that, it's just way too large and in charge. We need a smaller servo. So it's fine if it sticks out the side, but yeah, I think one of these servos is going to be too big. So if you centered it, it would be, you know, it would likely work because it could slide around this area. But, and then the other servo would likely be driving like over here or maybe on the other side, so they don't get in each other's way. So we could do heavy duty servos. I just think it might be more wise to do the smaller form factor. Just go with the micro servos. Nice. Yeah, I'm sure Alan had a few iterations before he got it right. The Rock'em Sock'em robots definitely need a few iterations before he get it right, I guess. Unfortunately, we are on hack number 10, and I'm guessing that this will go on for a little while longer. We might be going to hack part 12 or 13 by the time this thing is done. It's definitely the longest series for one in hack in particular that we've ever done. Probably the longest series on YouTube, because I was looking about on live, like searching up live hacks on YouTube, and you'll never guess which 2 live hacks came up on YouTube. Yep, just DJ and I. That's the only live hacks that are on YouTube. So nobody really uses that term yet, I guess. I'm guessing people will say like live stream or something to that effect. But yeah. Hopefully this I'm guessing, I think Josh Starnes comes up, and whoever else from our forums has done a live hack. I'm trying to remember. Who else has done a live hack? Oh yeah, Cardboard Hacker did a live hack. But he has, oh yeah, his old name is TechnoPro, new name, Cardboard Hacker. Add a wire to the internal pot. Yeah, what I'd have to do is use those Micro HDDs with a pot that can spin a few times. If I just do a wire to the internal pot, it won't be able to spin enough to get the linear action happening. So I have to, I'm guessing it would have to spin about, let's say 10 times to get enough distance for the linear action. And so I'm going to need like a 10 turn pot. I'm pretty sure I can find one of those. I don't have any at home, which is crazy because I have so many electronic components at home. But I'm guessing DigiKey will have something to that effect. Really, I do have multi-turn pots, but they're like this. If you can see that, this guy right here. So this is a multi-turn pot, but it is so hard to like get something attached to that I'd rather just buy something that has an easier way to attach stuff there. Because I don't know, like, you guys have a good way of attaching something that spins to that little tiny thing there? I don't know of a good way of doing that, so I'd rather buy a pot with like a larger form factor, and then I would wire that pot to replace the pot from the servo itself with a multi-turn pot. So I think I might be done what I can do tonight. Besides, like, I guess I could start on the design for the Tinkercad design for the linear XY system, but I don't know, guys. I don't know if you guys want to watch me struggle through making that. It doesn't seem like it would be very fun for you guys. So I think I might do that off stream. And I'm also hungry because as soon as I made that error, I was trying to troubleshoot stuff and I didn't get to eat yet. So it's probably a good idea if I eat something soon. And I'm out of water as well. So I will need something to drink as well. So I think that might be it for tonight. I'm sorry I wasn't on for very long. You guys know the reasons. If you want to get the full story, I guess, definitely check out the beginning of this stream once it gets posted. Here, let's give you a better view of cool stuff on my bench. There you go. as the closer. Yeah, have a good weekend too, guys. Thanks for stopping by, and I apologize that we've had to change plans on this project. That was a live and learn experience, I guess. It happens to all of us. Even this guy. I'm a technical guy, but sometimes, technical guys make mistakes as well. Yeah, thanks for jumping in, Justin. It's great to see you here. And Martha too. I don't know if she's still around. It says there's 5 people. I'm guessing I'm one of them. So yeah, maybe she's still on. We'll see you in a bit, Martha, if you're still on. And we'll catch you guys next week, and hopefully I'll have maybe a prototype designed, and I'll have some parts to put together, and we'll make this thing happen, and then we'll get back on track making the player versus AI happening. So that's me, the player, with the power glove, going up against the camera tracking robot on the other side that's going to be trying to punch me. And we'll make sounds happen, like let's get ready to rumble, and float like a butterfly, sting like a bee, and all kinds of other cool sounds that will happen during the match. And then we'll keep score. We'll have that little display to keep score. and it'll also count down, and we'll have a few animations on there too. We'll make it fun. And then we'll have also player versus player, so we'll have a joystick also connected, so somebody could use the power glove and someone could use a joystick, like, you know, your standard. Maybe I'll bring in a fun joystick, like a USB to Super Nintendo controller or something. Just be like Street Fighter style, I guess. Did you guys play Street Fighter? Let me know in the comments. I played it mostly on Super Nintendo, but I know there was a Sega Genesis version as well. The Sega Genesis version was not so good because you had to, I think, press select to, because you only have 3 buttons on the original Sega Genesis controller, so you had to press select to get to like the kicking, I think. So you had your regular low, medium, and high punch, or I think it was like, I don't know, I think it's fierce punch or something like that. Anyways, you press select and then you get your kicks, which is very kind of terrible. Until they came out with the 6-button controller for Sega Genesis, which fixed everything, and it was a happy day. Anyways, all that to say, we'll make it like Street Fighter. It'll be pretty fun, I think. So yeah. Hope you guys learned a little bit. I definitely did. And we'll catch you guys next week. Have a great weekend. See y'all later.